Hello everyone. Welcome to today's session on Technology, Innovation, and Artificial Intelligence for Global Health Implementation Research. In this lecture, we'll explore how emerging technologies and innovative solutions are transforming the field of implementation research, IR, helping to overcome barriers and significantly improve healthcare delivery worldwide. Throughout this presentation, we'll examine how digital tools, AI applications, and innovative approaches are being used to identify implementation bottlenecks, develop solutions, and scale effective interventions across diverse health systems worldwide. From this lecture, we will learn about the enhanced impact that AI tools can provide on implementation research. Some barriers or divides related to infrastructure, digital literacy, and cultural fit. And lastly, the importance of adapting to low-resource and diverse global health contexts. Let's begin with a quick recap of implementation research. IR systematically studies how evidence-based health interventions integrate into real-world settings, addressing various biological, social, economic, and political factors. The primary purpose of IR is to identify and overcome barriers to effective implementation, ensuring interventions achieve their intended health outcomes. In our digital age, technology, particularly AI, enhances IR significantly by enabling real-time data collection, pattern identification, and predictive modeling, which helps anticipate and solve implementation challenges more efficiently. Technology-enhanced IR has similar characteristics to IR but also adaptations that set it apart. Technology-enhanced IR is data-driven. It leverages AI and big data analytics to predict and address implementation challenges. Technology-enhanced IR is contextual. Solutions are specifically adapted to local infrastructure, culture, and resources. Technology-enhanced IR is multidisciplinary. It integrates knowledge from health sciences, technology, social sciences, and implementation science. Lastly, it is adaptive. It employs iterative strategies that evolve with continuous feedback, enabling real-time improvements. When implementing digital solutions, multiple domains interact. The intervention includes the digital health solutions and AI technologies. The outer setting includes economic, political, and digital infrastructure factors. The inner setting comprises organizational culture and technological readiness. The individuals involved are the stakeholders who have varying levels of digital literacy. Lastly, the implementation process comprises the methods to promote the adoption of digital interventions. Let's highlight essential digital tools reshaping IR, data collection tools, such as mobile health apps, wearable devices, and digital survey platforms. Analysis platforms, including AI-powered analytics, machine learning, and geographic information systems. Implementation support tools, for example, digital decision support systems, telemedicine platforms, and blockchain for supply chain tracking. All of these tools can be leveraged to transform the landscape of implementation research. AI plays a crucial role in modern IR through applications like predictive modeling, which foresees barriers and outcomes using historical and contextual data. Pattern recognition using machine learning to reveal hidden relationships among implementation factors. Natural language processing, NLP, which will help to extract insights from qualitative data at scale. Lastly, adaptive interventions, which will provide personalized strategies that evolve dynamically in real time. To illustrate, consider this example of an AI-enhanced tuberculosis (TB) diagnostic tool, achieving a remarkable 96% accuracy from chest X-rays. IR facilitated its integration into healthcare systems by addressing infrastructure issues, training needs, and workflow disruptions. Consequently, TB detection increased by 47%, a significant achievement demonstrating the value of IR in real-world settings. Technology-enhanced IR faces specific barriers known collectively as the digital divide. This includes infrastructure limitations, for example unreliable electricity and connectivity. Digital literacy gaps, for example differing technological skills among users. Resource constraints, for example limited funding for technology maintenance. And lastly, language and cultural barriers, especially when interfaces are not always tailored to local contexts. The digital divide presents significant challenges for technology-enhanced implementation research in global health settings. Successful IR projects must account for these barriers and develop appropriate strategies to ensure equitable implementation. To bridge these gaps, IR projects utilize innovative approaches such as offline-first designs, for example apps working without constant internet access. Similar to the Pura app, developed by Dr. Pascal and Dr. Jean Carlo. These solutions enable consistent data collection and intervention delivery even in remote areas with intermittent connectivity. Low-resource adaptations that are optimized for low bandwidth, energy-efficient usage. These adaptations ensure technology can function effectively within existing infrastructure constraints. Capacity building will help integrate digital literacy training within IR projects. This approach addresses both immediate project needs and long-term system strengthening. Culturally responsive designs will develop interfaces with direct local input, enhancing usability and adoption. These design principles improve adoption and effective use of digital tools. Mobile health applications have dramatically impacted IR by improving data accuracy, reducing data collection time, expanding implementation reach, and decreasing overall project costs. Mobile health technologies have revolutionized implementation research by enabling more efficient data collection, real-time monitoring, and expanded reach to previously inaccessible populations. These technologies are particularly valuable in resource-limited settings where traditional research infrastructure may be lacking. In rural settings, AI-powered mobile apps have significantly reduced maternal mortality by guiding community health workers to recognize risks and make timely referrals. This IR project resulted in a 32% reduction in delayed referrals and a 28% decrease in preventable complications, leading to its scale-up in multiple countries. Big data analytics allow IR practitioners to harness vast datasets from electronic health records, wearables, and social media. The chart illustrates both the volume of data generated by different sources and their relative value in providing implementation insights. While social media generates the largest volume of data, electronic health records provide the most valuable implementation insights per unit of data. One great example is of blockchain. Blockchain has successfully addressed supply chain issues, reducing counterfeit medications and improving supply chain efficiency. IR studies have been crucial in navigating technical feasibility and stakeholder acceptance for these blockchain implementations. VR technologies are revolutionizing training through immersive experiences, allowing healthcare workers to practice complex procedures safely, coordinate teams virtually, and build empathy by experiencing interventions from patient perspectives. What about implementation research with telemedicine? Telemedicine expands healthcare access to remote areas. IR has identified factors influencing telemedicine adoption among providers, technical requirements, and supportive policy frameworks, essential for sustainable integration into health systems. IoT solutions enhance IR by tracking vaccine supply chains, monitoring medical equipment utilization, and measuring environmental conditions, providing critical real-time data that strengthens implementation effectiveness. Please take a minute to pause the video and read through these examples. Digital platforms are transforming how research findings are shared and utilized, promoting rapid dissemination, interactive engagement, and context-specific adaptations for implementation strategies. Digital knowledge translation strategies transform how implementation research findings are shared, accessed, and applied. These approaches enable more rapid dissemination, interactive engagement with research findings, and context-specific adaptation of implementation strategies. Digital tools significantly improve the measurement of key IR outcomes, from acceptability to sustainability, through real-time analytics, automated data tracking, geospatial mapping, and predictive modeling. Moving beyond traditional paper-based and manual approaches. Feel free to pause the video to examine all of these digital tools. Looking forward, emerging technologies promise further advancement in IR. Edge computing will allow data analysis locally, without needing extensive internet access. Advanced AI can create self-learning systems for dynamic implementation strategies. Extended reality including augmented and virtual reality for remote training and support. Precision implementation will personalize interventions based on genetics, environment, and social factors. Sustainable digital capacity building for IR involves progressively enhancing skills from basic digital literacy to advanced data science capabilities. Investment in comprehensive training and continuous skill development is crucial for long-term success. This pyramid illustrates the progression from basic digital literacy to advanced data science capabilities needed for technology-enhanced IR. Effective partnerships are fundamental to technology-enhanced IR. Health systems provide implementation context. Academic institutions offer research expertise. Tech companies deliver solutions and support. Community organizations ensure local relevance. Government agencies provide enabling policies. Funders offer critical resources. In summary, technology and AI significantly enhance IR capabilities, but context remains crucial. We must remain vigilant about ethical implications and digital divides to ensure equitable health outcomes. We will cover ethical implications in depth in future lectures. The future of IR lies in progressively integrating digital tools and AI, moving from today's supportive technology to fully AI-driven adaptive implementation systems. Successfully harnessing these technologies requires balancing innovation with equity, maintaining local context, and continuously building digital capabilities. As we move forward, success will depend on our ability to balance technological innovation with equity considerations, maintain a focus on local context while leveraging global digital resources, and build sustainable digital capacity within health systems. The future of implementation research lies not in technology alone, but in how we harness these powerful tools to address the complex challenges of implementing effective health interventions in diverse real-world settings. Thank you.